today I'm trying out a new program. I'm going to play with things a little bit today and see what all I can do with it. But for now, I just wanted to be able to look at my screen and explain from home, which is kind of hard to do from here. So with this new program, I should be able to explain what's on my screen and record at the same time. And you can kind of see my face so I can talk to you a little bit easier. But I wanted to show you all what you're going to be doing tomorrow. So tomorrow, actually, so this will be today for you because you'll just be opening it up today. So the first thing you'll do is when you open up the slides, it'll make a copy for you. And so this is very much similar to the interactive simulation that we did a couple weeks ago. I had several people tell me that this was very, very helpful to be able to set up the ratios and try to figure out what to do because it gave such specific examples and gave directions of where things are supposed to go. So Ms. Batcher and I talked about it, and we made kind of our own for mass-to-mass stoichiometry to kind of walk you through, for the first time that you're doing this on your own, some steps for how to get there and make it a little bit easier for you to see. So once you open it, it's going to give you the first equation that you'll use to solve the first 4 problems. And on slide 2, and make sure you don't go into present mode. You want to make sure that you are in the mode where you can edit so that you can move these conversion factors around. These are all text boxes, and just like what we did last week, you're going to be able to move those text boxes where they go. And at the bottom of the screen are the steps that you need to take. And it's also color-coded so that you can see which squares or text boxes will go in which areas. So to start, the question says how many grams of aluminum would be required to produce 45 grams of copper? The step 1 says determine the known and drag it to number 1. The known here is 45 grams of copper, so you're going to go over where number 1 is green. And the only one that says grams of copper is this one, so you're going to drag that text box down, put it where it belongs. Number 2 is this kind of tan color, so number 2 is going to be over here, and we know that since we have grams of copper on the top, that on the bottom of this conversion factor will also be grams of copper, and there's only one box that actually says that, and that's going to be this one. So once you click on the text box, you can drag it where it belongs. So where did this number come from? Well, it shows you in the steps. It comes from the periodic table. That's the molar mass of copper. And anytime we go to the periodic table to get a conversion factor, that mass will always be equal to 1 mole. So when I pop up here to the blue squares for step 3, I have grams of copper on the bottom, so I'm going to need moles of copper on the top. And I'm going to drag that where it belongs. So step number 3 says mole to mole. This is your mole ratio. Remember what we learned last week was that all mole to mole ratios come from the balanced equation. I'm going to minimize my video here now so that you can see what I'm doing. So step number 4 is purple and 5 is purple because both are moles that come from the balanced equation. Since I have moles of copper on the top, I'm going to go to copper up here. It looks like I need 3 moles of copper based on the balanced equation. So I go to that text box and I drag it where it belongs. And I'm also going to go to step number 5 to the same set of purple, but now I'm turning this into aluminum. That's what the question says. And aluminum in the question, or in the balanced equation rather, has a coefficient of 2, so that means 2 moles of aluminum. And I'm going to drag that up here to number 5. Number 6 is blue again because in step number 4, we're going mole to mass. So I know that I need to go back to the unknown to set up 6 and 7. And anytime I'm using mass, I go to the periodic table. Since I have moles of aluminum on top, moles of aluminum will go to the bottom. And I know that from the periodic table, all masses are equal to 1 mole. Last but not least, I'm back to this sort of tan color again. So I'm going to go over here, but now I'm going to aluminum specifically. So I don't need those. I'm going to need this one. This one's kind of hard for me to move this text box up a little so I can get to this one. Well, there we go. And drag that where it belongs. Once you've got all of the conversion factors set up in the right spot, you're going to multiply everything on the top, multiply everything on the bottom, divide those numbers, and make sure that they are equal to the answer that is on the slide. The first 4 slides or first 4 problems that you're going to do already have the answers on it so that after you get everything set up, you can check to make sure your work is correct. But the last 4, you actually do not have answers for, and you'll have to put your answer in yourself. It also does not have things color-coded. It does still have steps, but they're not nearly as clear. So you have to kind of set things up on your own and see if you can get to the right answer. Make sure when you get to slide number 6 that you reflect on patterns that you noticed in these first 4 And then make sure when you submit this as your assignment today, you also put your reflection in the comments.